One of the most impactful applications of computer vision is object detection. It's not just about knowing what an object is, recognition, but also where it is in an image. This lecture will dive into this dual challenge. So, what's the difference between image classification, object recognition, and object detection? Image classification tells you what the main subject of an image is. Example, this image contains a dog. Object recognition identifies what specific objects are present, like there's a dog and the cat. Object detection goes a step further. It identifies what objects are present and where they are by drawing bounding boxes around them. Early object detection methods were computationally expensive, but modern approaches, largely driven by deep learning, are far more efficient. Key to these advancements are models like RCNN, region-based convolutional neural networks, and their successors, which first propose regions of interest and then classify and refine bounding boxes for each. However, a breakthrough came with YOLO, you only look once. As its name suggests, YOLO processes the entire image in a single pass. It divides the image into a grid and simultaneously predicts bounding boxes and confidence scores for those bounding boxes, as well as class probabilities for the objects within those boxes. After prediction, a technique called non-max suppression is applied to remove overlapping and less confident bounding boxes, giving you the final clean detections. Another powerful approach is SSD, single-shot multi-box detector, which also performs detection in a single pass, but uses feature maps from different layers of a CNN to detect objects at various scales within the same image, making it good at handling objects of different sizes within the same image. Object detection is fundamental to countless applications: pedestrian detection for autonomous vehicles, identifying products on a shelf in retail, detecting anomalies in manufacturing, or even counting people in a crowd. It's a cornerstone of many real-world AI systems. The speed and accuracy of modern object detection models have made them indispensable tools in computer vision. Next, we'll explore an even more granular form of understanding images: semantic segmentation.